Right, so it's time for our first session of the afternoon, and as you can see, AI and digital sovereignty is the title there. But let's see what we have. We've got a double presentation first, so I'm going to ask our next speakers to please join me on stage. Come on up. Give me a round of applause. Please. So we have Christof Fetzer, who is CTO of SContain, and Christoph Gerlach from Supermicro. So you're going to present together, so I will leave it to you. You have the clicker there. Take it away.
Hello, works. So, hello everyone. Do you have a nice lunch? Yes, hopefully that's great. That's really, really great. So, I am the Christoph from Supermicro, and yes, we are two Christophs here. And if we are reducing our acronyms to C&C, of course, this one stands for confidential computing too, which brings us to the topic. And don't worry, this one isn't another AI is great pitch. This is more than like a therapy session. Yes, a therapy session for AI-paralyzed telcos. Honesty with a bit of humor. So, quick question, who here thinks AI is essential for their company's survival? Hands up. And now, who's delayed an AI project because of security, regulation, or just a gut feeling it might blow up your career? Hands up too. So, congratulations, you are the world's first Schrödinger's telco, both desperate for AI and terrified of it. But let's face it, we are all tired of hearing digital transformation, like a Hogwarts spell. But here's the truth. You hold civilization's most sensitive data. The real-time movements of millions, connected car telemetry, and yes, the cat meme preferences of an entire continent. And that's not just a risk. That's your superpower. You just need to use it without burning down the theater. But when we look at the possible solutions out there, where all the data you already have is actually processed, we all realize one thing. None of them really fits. We have the option number one, the hyperscaler's hot tub. Just move it all to the cloud. And this means hand over your crown jewels and pay egress fees the size of a small country's GDP. The second one is the fortress. Keep everything on premise. And what this means? Your AI lab is Harold from finance running Excel macros. And the last one, the hybrid marriage. The best of both worlds. Meaning twice the cost and double the headaches. So what you actually need is option number 4. Where data is processed without being seen. It's like a magic, but it's called confidential AI or confidential computing. And now I will hand over to the other Christoph, and thank you very much. This one.
Thank you, Christoph, for the nice introduction. Let me go a little bit further here. So my name is Christoph, too, and I'm the CTO of SContain. But in my day job, I'm also a professor at Technical University of Dresden, one of our excellence universities here in Dresden. And I have been doing confidential computing research for the last 10 years. And the reason for that was I had another startup called Cloud and Heat. And the idea was to build edge computing 10 years ago, 12 years ago. And one of the replies that we got from potential customers are, oh, is that really secure? Because you have this physical or limited physical security. Somebody could just steal your computers, that are on the edge, not perfect physical security, and therefore we don't want to have our data on these computers that are in the edge. And so therefore I started to look into completely encrypted processing. These days we call that confidential computing. So that means that we always want to have all data encrypted. So in the context of AI, we call that now confidential AI, we want to make sure that all your data, so training data, is encrypted all the time. Also the queries that reveals lots about my work that I do right now. So every time I query ChatGPT, I reveal what I'm working on, and they see the code that I might generate using these tools. So therefore, I would like to keep all the queries also confidential, and I want to have assurance that my queries are not used to build competitive or competing systems. And also the models that I might invest in and build, I want to keep them confidential, secret, so that only I can use that. So therefore, we have this approach of confidential computing. So we keep all the data always encrypted. And we make it in this way that only code that is encrypted can actually see that data in the clear text. And moreover, the keys that are used to encrypt are only visible to the code that is actually encrypted in memory. So this sounds like magic, but it is not magic. It is confidential computing that we use. And we want to protect ourselves against adversaries that might have gained root access to our computers. So we saw this morning that we can use confidential, we didn't see that this morning. We saw this morning that we can use AI to protect our systems. But actually, if I'm an adversary, I can use AI also to attack your system. And there might be, at least there are some studies that say I might, as an adversary, be an advantage over the defenders, because as an adversary, I only need to find one exploitable vulnerability to gain access to your systems, while as a defender, I have to defend against all exploitable vulnerabilities that is in my system. Therefore, we actually make sure that we protect against all users that have access to our system, that they cannot read any data of our applications. So by completely encrypting all the data, we can protect against these adversaries that might have gained root access. And moreover, we can also outsource more. Because if I let my application be managed by some external party, I might not trust that external party. So by making sure, with the help of confidential computing, that you cannot read the data as somebody who takes care of the application, I can protect myself as an application owner. So therefore, we would like to protect ourselves from all users that have access to the system, that they cannot read our confidential data, so our models, our queries, our training data. And that might sound like magic, but it is in production. So we have been developing that platform for the last 10 years. And we have been now working for the last 3 years in being in production in the healthcare domain. So in Germany, we have this healthcare card where we can log into our data and also go to the doctors. And what we do is we work with one of the big German telcos, and we provide them with a confidential computing platform where the users can connect to their health data. And there are tens of millions of users that use that platform daily. And so we can protect the data using always encrypted data. And that is actually required by the German regulator, which is called Gematik, with the help of BSI, which is the German Information Security Agency. They set rules, and these are hundreds of rules, that define how we need to protect that data. And one essential part of that regulation is that nobody that has access to any part of our servers can see the data. They must not be able to change the code to access the data. Only the code that is approved, that runs on a server, can see that data, the health data. And that is in production, as I said, for a few years. And now of course, we are working on confidential AI together with NVIDIA and Supermicro. And there we are working on a blueprint for a scalable confidential AI, such that we can protect all the data that we need to protect, all the queries, all the models, and give you a blueprint for building such systems. So that this morning we heard about AI-native telcos. I would say we need confidential AI-native telcos. And now I hand over to Christoph.
But we learned a lot, but make it real. Make it real for your CFO, but let's make it real CFO-friendly. The German government say, our data can't leave the country. And the old answer was, then we can't help. And the new answer is, yes, we'll process it, we never look at it, and reprove it. And this opportunity only for the German government is roughly more than 2 billion. The second one is multiple operators share encrypted data safely. Nobody leaks secrets, everyone gains insight. And this means 30% efficiency boost and CFOs high-fiving in hallways. And the last one, I call it Edge AI for Knox. Tiny boxes everywhere and easy to steal. With confidential AI, thieves get only encrypted nonsense. And the result? Lower insurance and happy lawyers. Last but not least, and repeat after me, security used to cost us money, now it makes us money. Thank you very much for your time.
Thank you. Round of applause. Round of applause for our presenters. Christoph, come and join us on here. Yeah. Great, fascinating. Thanks very much for that. Really interesting insights there. Any questions from our audience? Right in the front row, Ahmed. Alex is running as fast as he can with a microphone.
Does your solution work with serverless environments, or it has to be, you have to have control on servers?
Sorry, can you speak?
Does your solution work with serverless environments?
Yeah. Oh, let me repeat it. So does the solution work for serverless environments? Yes, it also does work with serverless. So you have to be a little careful how you do serverless, but in principle, in serverless, you can start application without having reserved computation VMs, and that is exactly where you can use confidential computing. You have to, because you can prove that your serverless function is inside of this encrypted memory region, you can so-called test it, make sure that cryptographically that this is your code with your data that runs there. Okay.
Okay, so can you share any matrix that you have around latency that this brings and roughly the costs of implementing confidential computing, if you have?
Yeah. So for confidential AI, so you have, of course, by encrypting everything, you have some overhead, but it's, in our measurement, about 5%. So within 5% of native computation. So it's, I would say it's acceptable overhead for the extra encryption that you do. Okay.
Great, thanks very much. Can I ask a layman's question as a follow-up? Going back, actually, because you Ahmed asked the question there about serverless. Why is this an important question? Why are we talking about, will it work on serverless environments?
So sometimes it's more convenient to use serverless than, say, a Kubernetes cluster. So personally, I always, if I have certain workloads, I use Kubernetes clusters or cloud native. But for certain workloads, serverless is good because I don't have to reserve a cluster, so it can be more cost effective if I send just a service to a cloud provider like the Telecom, and then they run it, and I, as a user of that serverless functionality, I want to make sure that my data is protected in that serverless function. I think that's how I interpreted your question.
Great, thanks for clarifying, that's great. Do you have any more questions for, I guess there's one at the back there as well. Thanks, Alex.
Are you worried about Q-Day, and should we be worried about Q-Day?
Q-Day.
Q-Day, so when quantum computers can break.
Okay. I'm not worried about quantum computing. So we mainly use symmetric keys, so we can actually be post-quantum crypto safe in the sense that we use something that's called attestation, so it's kind of a magic how we provision keys into these encrypted memory regions. We can have everything symmetric, and symmetric encryption is actually pretty resistant against quantum computers. It's when you use public-private key pairs, there you have to be careful to be post-quantum safe.
Great. There's one more at the front here. Oh, the microphone's coming. Thank you.
Hi, thank you. It's a very interesting concept. What's the business model for telecoms? So who pays who for what and who makes what profit out of what?
Okay, so there, maybe I hope I can say that about German Telecom. They have, for example, a cloud that provides confidential computing. And so they have then workloads from governments and in the healthcare domain. And they have then an additional charge for confidential computing. And it's similar also in other hyperscalers, so you can provide computing to customers and you protect their data using this confidential computing, and you can have some extra charge for that. And if you're a local telco, you can also make sure that the data stays in that geographic region.
So is Deutsche Telekom the one and only you're working with, or are you trying to syndicate this with other operators? Is that your proposition? You're trying to get more partners?
So we have also other partners outside of Germany, also other European telcos that we work with. But of course, we want to have more telcos that use that technology, use NVIDIA, use Supermicro, and build a scalable, confidential AI platform. Of course, also outside of you.
Great.
Yeah.
Thanks very much. Do you have another question? This side, Alex.
You mentioned, obviously Germany has very, very strong governance as far as the data sovereignty is concerned. How are you seeing your story go beyond the bounds of just Germany? Because where often these are less, or they're less explicitly said there's a problem, and I guess people can ignore it. I'm just interested in what you're seeing in other countries.
So I would say that in Europe, I would expect there will be more push towards that. So there's an AI Regulation Act, and I think that is very important for Europe to regulate this, make sure that the data is protected. There is, of course, a different push in the US, but so there's less focus on protecting the data. And while in Europe, I would expect will be more and more push towards this solution to protect the citizens and their data. Okay.
Fantastic, great, thank you. Do you have another question? Well, we're here, we've got a lot of questions for this topic. It's very reassuring.
Yeah.
I think we might be clear in that case. I do have one from our online audience, related. It's quite a straightforward question. Does AI increase the threat surface for telcos, and how much of a problem is that?
So I would say yes. So as I mentioned, you can use AI to protect yourself against attacks, but there is this so-called defender's dilemma. So that means I have hundreds of millions of lines of code that run in my infrastructure, and if I'm the attacker, I need to find one vulnerability that I can exploit. And that I can use AI to find that. I can analyze all the Linux code, I can analyze all the software that is open source, and I can actually have a targeted attack. And if I'm a telco, I need to defend against all these potential attacks, and I need to have much more computing power than as an attacker. So therefore, there is some asymmetry that we need to take care of. And therefore, one way is to encrypt more, because then I can exclude some of the code base out of my what is called trusted compute base, so I don't need to defend against all vulnerability that are in my system.
Great, thanks very much for that. Right, we shall move on in that case. So let's thank our two Christophs, our presenters. Thank you very much. Fascinating.